Okay, so yesterday we learnt about the D'Alembert's principle, application of the D'Alembert's principle to the object which is moving in a rectilinear motion with respect to x and y axis. So what we did was we applied Fx, sum of forces in the x direction is equal to max, and sum of forces in the y direction equal to may for an object which was moving in a rectilinear motion. So we'll extend the same thing, D'Alembert's principle, to a particle which is moving on a curved path. So if there is a particle which is moving on a curved path like this, at every point on the curve, for it to remain in dynamic equilibrium, there should be a D'Alembert's force which will balance all the other forces. So for any particle which is moving on a curved path, acceleration is in two directions. This is the tangential direction and this is the normal direction. So you have acceleration in the tangential direction, you have acceleration in the normal direction. There are some forces which are acting in the tangential direction and some forces which are acting in the normal direction. For it to remain in dynamic equilibrium while moving on the curve, the sum of forces in the tangential direction should be equal to mat. Sum of forces moving in the normal direction should be equal to man. In other words, Ft, sum of all the forces in the tangential direction, should be balanced by an opposite force which is known as the D'Alembert's force, which is mat. Similarly, Fn, sum of forces in the normal direction, which is in the normal direction, should be balanced by an opposite force, that is man. Now we also know that at is nothing but dv by dt. And what is tangential acceleration? It is the rate of change of magnitude of velocity. Similarly, an, which is given by v square by rho, is nothing but the rate of change of direction of the velocity. Now, for solving numericals, there are some important rules, working rules. First and foremost, draw the free body diagram of the particle showing the forces. Mark all the forces of the particle and first decide which is the tangential direction, which is the normal direction. Apply the conditions. Ft is equal to mat, Fn is equal to man.